Chef Conf. My name is Bakh Inamov. I'm coming to you from our home in the San Francisco Bay Area. I used to work at Chef, and I think this is my 6th Chef Conf. We've been under shelter in place for a few weeks now. Like many of you, I used the time to pick up baking sourdough breads. Here's a crumb shot of one of my recent creations. I'm still working on improving my oven spring. If you want to share baking tips, you can find me in the Chef community Slack. These days, I work at Google Cloud. My job is to help customers define and execute on their multi-cloud security strategy. I'm here with my colleague Konrad, and we're honored and delighted to share with you some of the work we've been doing. In this talk, we'll tell you what it means to be secure by default, particularly in the multi-cloud world. We'll show you our PCI for GKE blueprint, which is a great reference for deploying compliant workloads on GKE. We'll then look at the CIS benchmark and PCI-DSS InSpec profiles for GCP. And finally, we'll bring the pieces together in an example CI/CD pipeline that deploys secure infrastructure and generates its compliance score. So, let's talk about secure by default. There are entire conferences dedicated to the celebration of the variety of scanning and detective tooling in the market. Established enterprise players and new startups promise to find the latest vulnerabilities in your environment as soon as they're published. This talk is not about that. In my humble opinion, detective tooling makes cloud security teams feel warm and fuzzy. Why, with the gorgeous dashboards and alerting? But organizations that rely on those tools to secure their environments end up playing a never-ending game of whack-a-mole. Let me share an example here. Recently, we were working with a customer who turned on security health analytics. This is a Google Cloud misconfiguration scanner. As a follow-up, the customer invited us to a meeting, and the agenda literally said, "We just turned on security health analytics, and it produced over 4,000 findings. What are we supposed to do?" Clearly, achieving security by default is not something we can solve by purchasing latest and greatest security scanners. Always shipping secure software requires rigor, collaboration, and a lot of repetition. Our focus should be on detecting and correcting security gaps as part of the software development and release promotion processes, with the objective of preventing bad code from shipping to production altogether. There are 3 areas that will lead us to better outcomes if we apply rigor, collaboration, and repetition. We need to start with pre-approved code. The goal here is to empower developers with easy-to-consume libraries, packages, toolchains, and processes that were designed in close collaboration with the InfoSec teams. These are often called blueprints, cloud foundations, developer scaffolding. Leaving developers to the mercy of the cloud provider's default flows or Stack Overflow code snippets is a recipe for disaster. Google Cloud, Amazon, Azure, all of the cloud providers' default flows are designed for ease of onboarding and ease of use, and not so much around security. The next area of focus is automated security testing. Security requirements need to be expressed as code and become part of your build and release process pipelines. Failures of those tests need to be treated like any other software defects and remediated accordingly. Elite organizations extend those testing capabilities all the way to their developers, what is commonly known as shift left, so that developers can get early feedback as they are building their app in their development environment. And Finally, you should take advantage of the preventative controls exposed by your cloud providers. In Google Cloud, those are called organizational policy constraints. And those prevent deployment of misconfigured resources, such as no Cloud SQL instance should have a public IP, or storage buckets need not to be open to the world, or VMs should be deployed onto shielded VMs. And so when we combine those three areas of focus, we can get to a place where known security defects don't ship to production. And then the fancy security scanners become really helpful, because instead of overwhelming us with noise, the tools now will detect security gaps that were introduced outside of our process, whether it was by a malicious actor or by a well-wishing human with access to production. And with this, I'm going to hand it over to my colleague Konrad, who will cover the technical details of the bodies of work that we built to make secure by default an easier journey. Thank you for listening, and please feel free to reach out via the Q&A session and the Chef community Slack. Have a great ChefConf, and I hope that we can get back to HugOps in real life very soon.
Thank you, Bakh. My name is Konrad Schieban, and I'm an infrastructure cloud consultant in the Google Cloud Professional Services organization. I work with customers on infrastructure cloud projects and help them be successful in Google Cloud. Okay, let's start looking at the PCI for GKE blueprint. The PCI and GKE blueprint contains a set of Terraform configurations and scripts to demonstrate how to bootstrap a PCI environment on Google Cloud. The project overview and the resource hierarchy can be seen on this slide on the right. The hierarchy contains 4 different projects. For instance, the network project, which contains network resources such as a shared VPC, a management project that contains monitoring resources and logging projects. It contains an in-scope project that contains part of a GKE hosted application that is in scope for PCI compliance, and an out-of-scope project that contains parts of the application that is not in scope for PCI compliance. And the PCI and GKE blueprint helps you to quickly deploy workloads that aligns with PCI-DSS standards in a repeatable, supported, and secure way, and is a good start and makes it easy to deploy applications that align with the PCI-DSS standards. So in a few simple steps, you're able to deploy, in this case, a sample application that is an online boutique, and it contains services such as users can browse items, they can add them to the cart, and they can purchase them. The PCI for GKE blueprint is available on GitHub. You can clone it from the link that is shown on this slide. On the right side of the slide, you can see a diagram depicting the microservices of the application. Part of the application that is in scope for PCI-DSS is hosted in the in-scope project and contains the front-end payment and checkout microservices. The in-scope project has been designed to address a range of PCI-DSS version 3.2.1 compliance requirements. But keep in mind that some PCI-DSS requirements are met by Google Cloud's infrastructure, but some need to be implemented by you. InSpec profiles can be used to audit your resources on GCP against compliance profiles such as PCI-DSS and CIS, and to assess your security posture. The CIS benchmarks are configuration guides that are used by governments, businesses, and really organizations in industry as well as in academia. And they often influence the security implementations and postures of many companies. We have published the GCP benchmark profile for CIS, which is the Center for Internet Security, on GitHub, and you can find it on the link provided on this slide. The profile is based on the CIS Google Cloud Platform Foundation benchmark version 1.1.0 and can be found on the website of the Center of Internet Security. The profile consists of 58 controls that are comprised of, in total, currently 207 programmatic checks, and they cover sections such as identity and access management, logging, networking, VMs, storage, and databases. And if you are interested, we would love to see your contributions and hear your feedback on the profiles. And we would appreciate any kinds of contributions in terms of raised issues on the profiles or pull requests or any kind of code commits. The PCI data security standards are required for all organizations that accept credit card payments. The profile that we have published on GitHub is based on the PCI-DSS standards version 3.2.1, and you can find them on GitHub on the link that is shown on this slide. And again, we look forward to your feedback on the GitHub repositories, and we look forward to your contributions, be it in terms of issues raised, pull requests, or code commits. Now let's look at how we can actually run the PCI-DSS and CIS profile benchmarks against our GCP infrastructure. So we have to start with cloning the CIS and PCI-DSS benchmark profile from GitHub to either our Cloud Shell or our desktop. There is a guided walkthrough available on GitHub for the CIS benchmark profile that can be used as a guided walkthrough to get started. As a first step, look at the inspec.yaml file, which sits at the top level of the repository. And it lists several parameters that need to be customized for your environment, such as, for instance, most importantly, the project ID of the project you want to run the profile against, and other parameters such as the required key rotation period that you define, regions to scan where your VMs or clusters live, and so on. Those parameters are specified in a file inputs.yaml, and that can be used to specify your custom inputs. So an example of that file, a really simple one, can be seen on this slide, and it contains the GCP project ID, in this case PCI-CIS demo, and GKE locations, which is a list of locations for your GKE clusters, and the GCE zones, which are 2 zones in US Central 1 in this example. Once that file is created from a terminal, if you're in the top level of the repository, run inspec exec and specify the input file under the parameter -- input file. An example run can be seen on this slide. The command that executes the inspec profile run can be seen on the top, and it's exactly the same as we have seen on the previous slide. And after it has completed, we can see parts of the output that is on this slide. But of course, it is truncated because there are a lot of checks. We can see in green that there are a couple of past checks, and in the bottom we see the summary of the profile run. In this particular case, 42 controls ran successfully, 2 controls failed, and 14 controls got skipped. Why got 14 controls skipped? Because there are simply some controls that are not necessarily applicable to your environment, such as, for instance, consider checks against MySQL databases hosted on Cloud SQL if your project does not have any MySQL databases. In that case, we have skipped controls. Initial runs of the CIS and PCI-DSS profiles were pretty inefficient and took a long time to complete. The reason why they were so inefficient is that they contain nested loops with cubic and quadratic complexity, which fetch the same resource information over and over from the GCP API, and those occur in several controls. To solve this inefficiency, we implemented a cache for common GCP resources such as GKE, Cloud SQL, IAM bindings, and so on. And those are reused across controls, and the cache is only populated the first time the cache instance is run. Cache classes are defined in a separate GitHub repo for reusability across the different profiles and can be found on the link shown on this slide. The classes use Ruby class variables to share the cache content across all instances that are created in separate controls. Using this cache, we were able to speed up the InSpec profile execution. And for instance, for the database section of the CIS profile, we decreased the runtime from originally 3.5 minutes, 210 seconds, to only 30 seconds against compliance benchmarks such as PCI-DSS and CIS. An automated validation process of new builds is important to detect insecure non-compliance as early as possible in the release process of new builds without impacting or minimizing the impact on developer agility. Cloud Build allows you to define CI pipelines in a YAML format for infrastructure as code deployments, such as, for instance, deployments using Terraform. An example for a Cloud Build implementation can be seen on the slide on the right. In that case, imagine there are earlier steps to deploy infrastructure using Terraform. Then subsequently, you would run an InSpec profile against the infrastructure that you just have deployed. In addition, you can create an output for a PCI report and store that report in JSON or even HTML format on Google Cloud Storage. What are reasonable acceptance criteria for new builds to pass? The controls in CIS and PCI-DSS benchmark profiles do not all have the same impact. They have different impacts with different severity, such as, for instance, low, medium, high, and critical. You may want to accept a small amount of lower impact controls to fail, for instance, less than 2 in more complex projects. But you may not want to allow any control with high or critical impact to fail. So in that case, the idea is to rather validate a score of a previous InSpec run than simply to determine the success of a build based on InSpec's exit code. To achieve that, consider using the utility InSpec tools by the MITRE Corporation, which is available on GitHub, to validate the JSON output of a previous InSpec run. In the case of a Cloud Build application implementation, there is an example here in the bottom of the page where a compliance validation would require 90% of all checks to pass without any failed check with critical or high impact. InSpec can be used to validate infrastructure deployments against compliance benchmarks such as PCI-DSS and CIS. An automated validation process of new builds is important to detect insecure non-compliance as early as possible in the release process of new builds without impacting or minimizing the impact on developer agility. Cloud Build allows you to define CI pipelines in a YAML format for infrastructure as code deployments, such as, for instance, deployments using Terraform. An example for a Cloud Build implementation can be seen on this slide on the right. In that case, imagine there are earlier steps to deploy infrastructure using Terraform. Then subsequently, you would run an InSpec profile against the infrastructure that you just have deployed. In addition, you can create an output for a PCI report and store that report in JSON or even HTML format on Google Cloud Storage. Thank you so much for listening. Please check out our work on GitHub, such as the PCI for GKE blueprint, that allows you to quickly deploy an infrastructure and an application hosted on that infrastructure that aligns with PCI-DSS standards. And check out our CIS benchmark profile and our PCI-DSS profile for InSpec. Both can be found on GitHub, and we appreciate any kinds of contributions, be it in terms of issues, any feedback that you have, or pull requests.